Class discussed with respect to the lab number 4. Now we can discuss with respect to the lab number 5. Okay, that is the solution of the first order differential equation and plotting the solution curves. What is our aim? Make use of that Python codes that uses to find the solution of the first order differential equations and plotting the solution curves. Okay, you can make use of software Python Colab in online mode for the Jupyter, IDLE, or else Visual Studio. Okay, then we can discuss the MATLAB also be same. Then first order differential expression is what? I need to define a particular expression y that I did with respect to one-time derivation corresponding to the variable x. That is f of xy or dy upon dx is called as first order differentiation. That can be represented by y dash is equal to f of xy or else dy upon dx with respect to the y. That is d upon dx is equal to y. Y, that is f of xy. Okay, this is what the representation. Okay, corresponds to that the whatever the syntax we are going to use, dissolve, differentiation, derivative, same thing we can discuss. Okay, directly we can proceed for what? The lab execution itself. Now it is what? The solution of the first order differential expression and plotting the solution curve. Among that, first example is to get the solution of the differential expression dp of t with respect to the t which is equal to r. Okay, so that I need to initialize the whatever the printing function which ought to be present. Okay, so that init underscore printing the whatever the output I need to display. Then defining of symbol, that is t comma r, that is t and r are the symbol. Then p is what? It is the function of p corresponds to the t. C1 is equal to what? Symbol of C1. Then what I need to do? I need to get the differential expression so that I am getting that as a differential equation. That is the differential equation 1. The derivative of p with respect to the t corresponds to the order 1 minus r. Okay, display that particular expression. Okay, general solution. I need to get that solution so that GS1 is equal to D solve. What is my expression? dp upon dt. That is what? DE1. Okay, display that general solution what you are going to get. Then particular solution. What I need to do? I need to substitute that GS1 with respect to that of the whatever value you are going to call as the symbol C1. So that I am representing the C1 corresponds to the 2. Then if you substitute it, then that particular value what is to be present for the particular expression PS1 will be present. Okay, then what I need to do? I need to take this code. I have to type this code in any of the Python platform. Okay, I will go with Google Colab. Google Colab. Then new. I will go for new notebook. I have to rename it. What is this? Lab number 5. Lab 5. Today I am discussing it. So that I am giving that date because I have to get my reference. Okay, I have to type this code. Okay, already I discussed it. Initiating of this particular value, defining of symbol, then what is the function is to be presented, then what is the constant value, then I need to derive that particular expression, then I need to get the general solution, then I need to get the particular solution. Okay, these are to be present. Once you type this code, then you have to run. Okay, whatever solution is to be corresponds to that first order differential equation, you will get that solution itself. Now you got here minus r plus d differentiation of t corresponding, that is p of t with respect to the t. Then what is general solution? P of t is equal to C1 plus RT. Then particular solution is what? RT plus 2. Okay, once you did this in manual solution, you will get the solution itself. Okay, this is what the expression is to be represented in order to get the proper solution itself. Then second, what I need to do? Simply I have to go for code. Okay, then I will take second code. I will take the same. That is dy upon dx plus tan of x minus y cube into sec x is equal to 0. Okay, symbol are defined. We got two variables, x and y. Y is what? It is the function. Okay, so that y is equal to function of y corresponds to the x. Then calculate y primitive. Y prime is equal to derivative of y comma x. Then differential expression diff underscore equal. Okay, then equation y prime plus y into tan x minus y raised to 3 into sec x at the value what? 0. Okay, then I need to get the solution for that. Then I display that solution. Just I have to run this code. Now you got the expression. Okay, that is y of x is equal to what? Minus square root of 1 divided by c1 minus 2 sin x into cos x, comma y of x is equal to square root of 1 divided by c1 minus 2 sin x into cos x. Okay, this is the what the solution was to be present. Okay, because the same solution we will get displayed. Because of that reason, we are getting that output itself. Later I will go for new code. Okay, here also be different expression. Okay, that is x cube into dy upon dx minus x square into y plus y raised to 4 cos x equal to 0. Okay, for this expression, we have defined symbols, we defined function, then we have defined the y prime as a derivative functionality. Later we are getting that differential expression. We need to solve that solution. We have to use the dissolve. That is the what? The differential solution. Then we have to display that solution itself. Solution is what? It is variable. That is not the command. Keep this in mind. Here corresponds this output you are going to get. Whatever the expression is to be required here. Y of x, then cube root of x cube divided by c1 plus 3 sin x. Then with respect to that, the another solution corresponding to that expression is y of x cube root of x cube divided by c1 plus 3 sin x into minus 1 minus root 3i divided by 2. Okay, then similar to that of the another expression. One is positive value, another one is negative value because of the complex number what is to be present. Okay, another one is what? I need to get the solution that with respect to the plot what are to be get defined. Okay, to define that plot, we are proceeding with respect to that particular expression what should be get defined. Okay, that is what the 5.2. Okay, numpy I am calling because this is my expression dy upon dt is equal to minus ky, k is equal to 0.3, then y of 0 is equal to 5. This is my initial values. Import numpy, then from scipy dot integrate because I will be having the integrating functionality also. Then I need to get the plotter so that math plot lib, okay, py plot which can be taken as a what? Plot. Okay, this will be taken as a audit. Okay, then whatever is to be present for that function I have to define it. Differentiation of model y with respect to the t, k equal to what? 0.3. Okay, then dy upon dt, that expression we defined, that is return minus k into y. Okay, then initial value is y equal to 5. That is y not equal to 5. then t is equal to np line space 0, 20, because I have to define a particular range. Okay, within that range, it has to do its evaluation. Then orient model, then y naught, and the t values what are to be present. Then I need to plot the same. Okay, plt dot plot t comma y. Then title I am giving. Then what is this x parameter? What is that y parameter? Then displaying the same. Then I will run that code. Corresponding to that, I will get the solution here. dy upon dt is equal to minus ky, k equal to 0.3, y of 0 is equal to 5. Okay, corresponding to that, we'll get this plot. Okay, this is what the plot, we need to get the solution, what is to be present in the particular network, what are to be get defined. Next code will go. Okay, here another this simulate to, that is dy upon dt is equal to minus y plus k pu, then kp, that is kp into u, kp is equal to 3, tau is equal to 2, because tau they have defined as one variable, kp is defined as another variable. Kp equal to 3 we are defining taup. Okay, that is the representation of tau. Okay, that is what 2 value. Okay, corresponds to that, I will get that expression. Then differential model, y equal to 1, then expression I have to define. Okay, then corresponds to that time parameter 0, 14, 100. Then y3 parameter, then corresponds to that t3 what is present, corresponds to the model taken as a 0. Then plot that particular graph by giving the title, then corresponds to that x label, y label, then whatever the lesson value what is to be get as a display, then corresponds to that particular graph have to be shown. Okay, then once I type this, then I have to execute. I got. Okay, here the whatever the output you are going to define, label this graph. Okay, that we are defined as here label ODE integrator. Okay, this is the what the solution what you are going to get. Okay, corresponds to the response of y, corresponds to the time. Okay, those values are also we are defined here 0 to 14, 0 to 14. Okay, then values what we are going to get t3 corresponds to that response of y what is to be present, corresponds to the expression what you are going to define. Okay, another go to code, then another code you have to type. Okay, py lab, then 10 we are defining here. This is also one type of library. Then t is equal to arrange 0, 10, 0.5. Then p naught is equal to 20. Then y is equal to 20 into exponential of that particular value. Then plotting that particular result itself. Okay, then I have to get that execution because plot of t of y. Okay, this is the what the natural graph what is to be present. Okay, once you refer that manual, in that manual the expression what is to be there correspond that it is to be defined. Okay, this is how we need to execute. Then last code, Newton's law of cooling. Okay, numpy we are calling, simpy we are calling, matplotlib we are calling. Then t2, then t1, 20 and 100 we are defined. Then later t is equal to 10, capital T is equal to 75. Then k1 is equal to 1 divided by t into log of t1 minus t2 divided by capital T minus t2. Okay, now to make that k calculation itself. Okay, later we are defining small k as a symbol k, then small t as a t, then capital T as a function capital T corresponds to the t. Then I want the expression corresponds to that capital T is equal to t2 plus t1 minus t2 exponential of minus k into t. Okay, then I need to plot the same corresponds to the graph what is to be required. Okay, once I did, then I need to make the evaluation of that particular graph what you are going to get at a t is equal to 30 minutes. Once you type this code, just to click on run. You will get that particular graph itself. Okay, what is the value of k? 0.037469. Okay, capital T is what? 20 plus 80 into exponential of the minus k into t. Then you will get this output graph. Okay, this is how you need to execute your Lab-05 codes. Okay, once you can go through this, try to execute by yourself without typing these comments. Okay, then you will get that output. Make the alignment properly, then you are not going to get the indentation error. Okay, practice, execute. Still, if you are getting any doubt during your offline class, we can discuss the same.